Okay, thank you for joining today's webinar. We're going to go ahead and get started here. My name is Trevor Brown. I'm Business Development Manager for Juniper Systems, and I'm joined by Ryan Pearson. He's our Utilities and Public Services Account Manager at Juniper Systems. He also has a lot of experience with field data collection for local government right here in Utah. And the topic of today's webinar is inexpensive sub-meter GPS options for Utah's local governments. You're going to recognize a lot of the scenery in this webinar. The Utah landscape has really inspired a lot of our marketing materials as well as our product's rugged design. Okay, we're going to start by doing a brief introductions for Juniper Systems. We're then going to talk about two of our products that are ideal for local government field data collection in Utah, the Mesa 2 rugged tablet, as well as the Geode sub-meter GPS receiver. Then we're going to spend the majority of our webinar focusing on three common workflows in Utah local government. The first being a traditional GIS workflow, a Trimble alternative, and an ESRI Collector workflow, as well as a form workflow, essentially is replacing your paper forms. Now we're going to keep this short and sweet. We recognize that everybody's pretty busy and it's just before lunch, so we want to keep this to 30 minutes or less, and so we should be done just about at 11:30. And if you have any questions along the way, please ask those in the question chat box in your GoToMeeting, and we'll be sure to follow up with those either real time during the meeting or certainly after the webinar. So feel free to ask as many questions as you like. Just write those in the webinar chat dialog questions box. Okay, if you don't know our company is Juniper Systems, and we are field data collection experts. We've been in business for just over 20 years, and we work in a wide range of industries, everything from agriculture to public services to natural resources, land survey, but also a lot of local government field data collection. So we do manufacture all of our devices to be ultra rugged, and our parent company is Campbell Scientific, and we're both located up in Logan, and Campbell Scientific is just across a cow pasture from our factory here in Logan. So reliability is kind of a key goal for our company. We want to make sure that all of our products are protecting our customers' data, and we also have a very high commitment to quality. We maintain one of the lowest failure rates in the industry. So we are a Utah company, however, we do have a global reach. We are working in about 80 countries worldwide. We do have our factory, our main headquarters in Logan, Utah. We do also have an office in the United Kingdom. We also have two offices, one in Kansas City and one in Austria, that are both serving our agriculture customer base. So we are a Utah company, but we do have a pretty far reach, and our products are used around the world. All right, the topic of today's webinar, local government field data collection, we're going to be focusing on two of my favorite products. One is the Mesa 2 rugged tablet, as well as the Geode sub-meter GPS receiver, and that is our newest product here at Juniper Systems. And so here's the Mesa 2 rugged tablet, and you see it here pictured with some scenery in southern Utah. And really, essentially, the Mesa 2 is a Windows 10 tablet. The difference, and this would be just like your desktop computer or a tablet or other Windows laptop. The difference is this is designed to fit well in the hand. It's ergonomic. It's ultra rugged, so it's something that can be used in the office. But then it's a nice size and has all the features you would expect in a mobile device when you take them out to the field for your field data collection. As with all of our products, we make sure that the Mesa 2 has a full day's battery life, running at about 8 to 10 hours. You can get an optional upgrade to increase the battery runtime an additional 4 to 5 hours, and then you can take the battery out and swap it out, just much like a flashlight battery, for example. It has a high visibility display. The screen is very bright. and it's visible in direct sunlight. It's also super tough. It's a chemically strengthened glass that is scratch resistant as well. All right, as with all of our products, it's built Juniper rugged. That means it's dustproof, it's waterproof. It's the only IP68 rated Windows tablet on the market, and it can withstand multiple dropped concrete. And it's backed up by a strong warranty. And all of our products can be used in extreme cold, heat, humid type temperatures as well. And then lastly, with the Mesa 2, it has all the features you would expect to be able to communicate with other devices. It has long-range Bluetooth, it has Wi-Fi, it has an optional cell modem, 4G LTE. It does have both serial cable and USB connectivity. It does have an optionable high-performance GNSS receiver. It does have an 8-megapixel geotag camera, so you can take georeference photos in the field, and you do have options for barcode scanner and RFID readers if that's the type of data you're collecting. All right, the other device that we're going to be reviewing today for local governments is the Geode sub-meter GPS receiver. And here's some kind of basic specs about this receiver. It's our newest product, as I mentioned. It is a real-time sub-meter accurate device you see here. So it's using SBAS satellites, the WASP network, in the air to basically give you real-time sub-meter accuracy. It's affordable. It's quite affordable. It's an all-in-one receiver, so meaning that it's a receiver and antenna in one. You don't need to attach other cables. It's compact size. It's a really nice size. It's an open interface, meaning that the Geode can be used with any of the Juniper Systems handhelds, but it can also be used with your own Windows device or Android device, such as an Android smartphone or tablet. It does have an all-day battery life, just like all of our other products, so it's meant to get a full day's use. That's continuous as well. And it's built Juniper rugged, just like our other products. And lastly, one of the most important things, it's very easy to use. All right, so here's some just example pictures of how the Mesa 2 and the Geode can be mounted and used in data collected in the field. So this is a very common one on a survey pole, and the Mesa 2 is compatible with off-the-shelf RAM mount parts. Customers can utilize a magnetic mount to show it on a vehicle or an ATV, for example. Data complete, and this is one common way that I like as well. You can just utilize a collapsible camera pole, and this is a really inexpensive option. It costs about $15 in any kind of big box store, but the thread in the Geode receiver allows for the size of inexpensive camera equipment and accessories. Here's a picture of that camera pole used as a monopod and data collected that way. Here's that same pole being used in a backpack. So all of the positions are being taken right where that Geode is situated. And we also have a smartphone tray, so that Geode can be paired with a smartphone and collected in a very compact manner. And the Geode works really well. So here's a representative Geo Test that we had here at our factory. There are 4 data points collected. And you can see that this is a pretty typical way to collect the data. So we weren't using special survey techniques or anything like that. And these were 60-second average points. So on those points, the circle that you see is a 1-meter radius. And all the positions are landing directly smack in the middle of that 1-meter circle. Here's the other 2 circles that were collected at the other positions. Here's some additional data. So the difference on this diagram is that the circle actually represents a 1-foot radius, 0.3 meters. You see most of the data points landing right inside the 1-foot radius. So not only is this sub-meter, it's well below sub-meter. And we measure all of our and communicate all of our accuracy data to a 2 sigma 95% confidence. So we want to make sure that we're communicating that in a standard way. So there's the real-time accuracy of the geode. If you need higher accuracy, you can post-process your geo data. So here's that same 1 foot or 0.3 meter radius circle, and now you see all of the data right within about a 10 centimeter or 0.1 meter position. And the interesting thing, this diagram, just that orange box that you see there, that represents the physical size of the geode receiver. And when we talk about horizontal accuracy, we did see a question come in related to horizontal accuracy. And horizontal accuracy is, as with all GPS, you can get excellent horizontal accuracy, but kind of a rule of thumb that we know and that's used commonly is about 1.7 times your or if we're talking about vertical accuracy, it's about 1.7 times your horizontal accuracy. So, the higher accuracy you have, the better vertical accuracy you have, but definitely we can answer that question in more detail. Okay, now we're going to talk about the workflows that are common within local government and how these two products can be used within those common workflows in Utah local governments. So the first one we call traditional GIS workflow. So this would be something common with Trimble products, for example, where customers are used to using those types of products. This would be an alternative workflow to the Trimble solution. Okay, so just as a high-level process overview, on the left, you essentially plan your product. This is where you're exporting your data from a GIS. You have the process of collecting your field data. You then want to post-process the field data if that's what you do, and that's an optional step. And you can then upload all of that data to your GIS. On the right, it shows the tools that are used in that process. So instead of using Trimble TerraSync, for example, you can use EasyTag mobile software. Instead of using some expensive survey equipment, you can use the premium Mesa 2 rugged tablet, as well as the Geode sub-meter receiver. And finally, if you are post-processing, instead of using Pathfinder Office, you can use the EasyService post-processing software. Now, in that step 1 planning, within EasyTag, you do have the ability to create a custom data dictionary. And this is a great way to standardize how your data is collected and also make it very easy on your field crew to collect that data and make sure that you, as the data manager, get the information you need from the field crew. So that is an optional data dictionary that you can set up. It's packed with features and easy to set up and use. Within EasyTag, however, you also have the ability to clip a web map directly from the within EasyTag, which allows you to have background imagery and very easily have background imagery on your mobile device. But you can also upload your own high-resolution maps, such as Geo Test, JPEG, etc. All the common file formats for high-resolution maps. Lastly, you can also copy shapefiles directly to your Mesa 2 and view those while out in the field. So all of this data you could then view out in the field. They're all optional. You don't have to do these steps, but you can go and view those out in the field. Next, within step 2, in collecting your field data, EasyTag, here's a screenshot of EasyTag. Here you see that same data dictionary that we had created in the previous slide, now as available as options out in the field. And once your users select that particular feature, it would then guide them through the list of questions that you had set up or attributes that you want them to fill out about that feature. And EasyTag, just as a general note, it's a full professional GIS software with all of the kind of functions you would expect. It allows for users to collect points, polygons, lines, averaged points. It allows for users to integrate other equipment like barcode scanner, rangefinders. It allows for users to navigate to points, to view all of that data that we talked about in the previous slide directly on your handheld. And it's really quite an easy to use and easy to train, more importantly, software, and it allows for users to create some very professional maps. All right, so here's the optional step of post-processing if you require higher accuracy data. The first thing I always tell people when they look at EasyServe is you see all of these icons and other features that exist within the software. This is a very professional software. It's made by the same company that makes EasyTag. It's made by Effigus in Montreal, and they have a lot of features and functionality in the software, but it's really not very intimidating in the sense that once you learn how to do it, all you're doing is you import your data, you browse to that file, and you then push the button to post-process your data, and then it's automatically taking your data and it's comparing it to a base reference station that's closest to where that field data was collected. And then and as a reminder, it's refining that data. So there's the Geode real-time accuracy of about 30 to 50 centimeters, and producing a result of about 10 centimeters post-processed. This is something that we've tested over and over again, and we've also tested this, the accuracy of the Geode, both real-time and post-process in a number of environments. The Geode works quite well in challenging GPS environments as well, such as under trees, in canyons, in urban canyons around buildings. It's one of the better receivers I've ever seen in those environments, and certainly the best that I've ever seen at the cost and price point of the Geode. All right, and the last step in this traditional GIS workflow was to upload your GIS data. This is essentially just exporting the data that you collected in the field or post-processed, and you export it to common file formats such as CSV, KMZ for Google Earth, shape files utilized in most GIS, as well as you have the option for an AutoCAD DXF file format. Okay, if we look at a cost comparison, how much does all of this cost? And if we compare it to our competitors, here's some typical competitive prices. You know, when you have to buy a data collector plus your GPS, essentially your hardware, we often see one of the most common cost about $6,500. The field software costs about $1,300. The post-processing software about $1,500, for a total price of about just over $9,000. With our solution, you get the premium Mesa 2 for $1,600, the Geode receiver at $1,500, EasyTag field software at $675, and EasyServe post-processing software at $500 for just over $4,000. So it's a very big cost savings for local governments who we know are often, have to be very conscious about budgets and how they spend their money. And we also wanted to talk a little bit about, if you are on a pretty tight budget, depending on what you're doing, there's some other options to be aware of. So we have a couple of tips on how you can save even further money. So one, if you don't need real-time sub-meter accuracy, you can choose to get an upgraded internal receiver inside the Mesa 2 Geo, so you're not using the Geode, and you can save a lot of money there and just paying just over $2,300 for your hardware. You then still buy EasyTag and EasyServe, and you can get a sub-meter accuracy map and result for just about $3,500. Another way to save money with this solution is if you're using 3 or more GPS receivers. So if you have a crew of these or a fleet with your local government there, you can just buy the EasyServe Open license, which is $1,500 for your post-processing. So you don't need to keep buying license over and over for each receiver. So if you have more than 3 or more, it really starts to add up in your savings there. Okay. The next workflow example that we're going to cover is the ESRI Collector workflow, which is ESRI's most current mobile field data collection workflow. And I'm going to turn it over to Ryan, and he's going to talk about that there.
Thank you, Trevor. The ESRI Collector is a powerful application that typically is used with the ArcGIS Online services from ESRI. Alternately, the ESRI Collector may be used with the ESRI Portal product for those who have it. All ESRI software customers who are current with their software maintenance are entitled to an ArcGIS online account and the associated tools and apps. The ESRI Collector app is one of the many ArcGIS online tools available. I'm going to be presenting the workflow associated with using the Collector application within the ESRI platform. As you can see on this slide, there are 5 keys to successfully completing a project using ESRI Collector. I'll address each of these 5 keys in subsequent slides, but I wanted to introduce them here. To properly execute a mapping or data collection project in local government, it is critical that proper planning occur, that the necessary resources are available to build the project, that the project is shared appropriately to the organization, that field work is properly supported, and that the project is supervised and monitored with the proper adjustments made. On the next slide, properly planning an ESRI Collector project is presented. You want to go ahead and move that, Trevor? So the importance of planning an ESRI Collector project cannot be overemphasized. Perhaps this is the most important key to successfully completing the field mapping project. The first step to planning involves clearly defining the purpose of the project. Once the project purpose is defined, the project method becomes easier to envision. Based upon the project purpose and the project method, it's important to identify the required resources needed to complete the project. This includes things like personnel, IT resources, field technology tools like the GPS and field PCs that Trevor introduced with the Mesa 2 and the Geode. As the project is being planned, it is always wise to set project milestones and to measure that progress, especially when working cooperatively with other departments or even other agencies. These milestones help local government organizations see that the project is being completed successfully. On this next slide, I'll be talking about the steps to build the project. Using the ESRI platform, the tools are available to quickly build a solid collector-based project. A combination of tools in ArcGIS Desktop and in ArcGIS Online are available to build a project. This includes determining which background layers you would want to deploy to the field crew, what vector data sets you would want them to have access to or to interact with or to view, and of course which data to collect. Designing a proper database schema is an important key to the project. This schema could be one of your own design, or it could be a publicly available data set, similar to the Public Works schemas available from ESRI. Evaluating existing data that may be used for the project is another key to building the project. Simply using tools in ArcGIS Desktop, publishing map services, feature services to be used by a collector application is a necessary step. This is a simple process to publish the map services and feature services. Once a project has been built using the tools in ArcGIS Desktop and ArcGIS Online, it is a very simple process to share the project with the group. ESRI identifies this as a work group, people that are invited to participate in the project. Once the work group is defined, you can share that, as you can see on this slide, to the work group. This would make the online maps, the project that's been created, it makes that project available to everyone in the work group to interact with, to view, to monitor. Once the project is shared, I think it's important to test that application through pilot projects. Take a small area, send your field crew out, test that project a little bit to make sure it meets the vision that you have for that project. On the next slide, we'll talk about data collection and what is required for data collection. So once that ESRI Collector application has been built and it's been tested, it's time to put boots on the ground and begin to collect and update the data. During the data collection process, it is important that the project manager supervise and coach those field personnel. By doing this, it gives the field personnel confidence and allows the manager to monitor the progress too. Based upon progress, the manager may assign specific tasks to members of the work group. This is all done through the ArcGIS Online tools and through monitoring tools. As the manager coaches the field personnel, methods to increase efficiency may be revealed too. If the project is properly planned, the proper resources in place, and the field personnel are properly coached, then the ESRI Collector data application project will be rapid and accurate. On the next slide, we'll talk about the importance of supervision. To successfully operate through a collector application, it's very important that you have proper supervision. Supervising the project will reveal opportunities to improve the workflow, will build the confidence of the field personnel, and will ensure that the project is being completed as it was envisioned during the planning stages. ESRI provides tools like the operations dashboard that you see on this slide to monitor the progress of the ESRI Collector projects. I think it's important to regularly provide updates to members of the work group and to any agencies you may be working collaboratively with. Being able to demonstrate progress to all the stakeholders builds trust, and it also energizes the group. It gets support from people who are participating in the project. If the project is progressing very well and solid results are being realized, then it's important that you share that information with others. It's okay to promote your successes. This emphasizes that the ESRI Collector project was planned correctly. That completes the 5 steps of successfully deploying the ESRI Collector. I want to talk about now some of the advantages of the Collector solution and some of the challenges to the ESRI Collector solution on this next slide. So the advantages are what you would expect. The ESRI Collector being a cloud-based service through ArcGIS Online, it's ideally suited for supporting collaboration between individuals within an organization or even collaboration between multiple organizations. I think that is one of the greatest strengths of the ESRI Collector solution. The ESRI Collector application provides great flexibility in workflow and in the technology platforms that would be used in the field. Near real-time update, being able to view the results as it's being completed is important. However, there are some challenges to consider when deploying an ESRI Collector-based application. Number one is something I've already emphasized. The success of a ESRI Collector application depends heavily upon proper planning and execution. It's important to make sure that the resources that are required to successfully complete the project are in place, and that the agency or the organization where you're working support the project. If there's a lack of resources or support, then that could be a challenge to successfully completing a project. Of course, training and guidance for the field personnel, for others who are collaboratively working on the project is a challenge at times, so that needs to be considered. As was mentioned, the field hardware and peripherals, things like the GPS, GNS receiver, are things that should be considered. Choosing the wrong field technology can really be a detriment to successfully completing a project. On this next slide, I want to talk about the field equipment considerations and then re-emphasize the capabilities of the Mesa 2 and the Geode in relation to successfully completing these ESRI Collector projects. Field equipment technology may be the most underestimated key to successfully completing an ESRI Collector project. It is frustrating to field personnel, the very people responsible for most of the work, when the field technology doesn't meet expectations or even fails to work at all. Consider the field PC platform and operating system, whether peripherals are required like barcode scanners or camera. Consider location accuracy requirements, network connectivity, and equipment durability that meets the demands of the environment. As Trevor emphasized already, the Mesa 2 rugged field tablet PC and the Geode GPS GNS receiver are fantastic options for successfully completing an ESRI Collector project based on what you see on this slide. The accuracy of the Geode meets or exceeds most requirements in real time and post-process. The Geo does support both SBAS and NTRIP, so those here in Utah can take advantage of the turn network with the Geo for network corrections using cellular data communication. The Mesa 2 does have the option for a 4G LTE cellular data modem, so you can connect to the network very easily. Mesa 2 does offer the Microsoft Windows 10 operating system, so the latest applications, latest functionality are available there. They're both extremely rugged devices, very portable and ergonomic, and they are manufactured and supported right here in Utah, which to me is a huge bonus. That kind of completes the workflow that I've put together for completing successfully an ESRI Collector project. I'll turn the time back over to Trevor at this time.
All right, thanks, Ryan. So the last workflow we're going to talk about is a pretty practical one. It's one that I really like. We call it the form workflow, but this is basically a way to replace the burden of managing a bunch of paper forms. So if you have a lot of paper forms in your organization for your field data collection, this is a real nice and straightforward way to, and affordable way to replace those paper forms with electronic field data collection. And you can use it with the same equipment that we described for your GIS data collection. So these tools are being used for different jobs, essentially. Here you have on the left, you have your typical paper method where you create a spreadsheet or some kind of database and you create your paper form. You then go out into the field and record that paper data. And then you come back to the office and manually enter that paper data back into a spreadsheet or into your database. And along the way, you may have tried to also integrate things like GPS, photos, RFID, or barcode. Integrate that data manually to your paper data collection process. We're going to focus on the right side here, where you have a process where you have a little bit of work up front to create a mobile app. It's easy to do. You don't have to be an information technology expert or a programmer. You can create your own app, and you can then go, instead of using paper, you enter data into the field PC, allowing you to keep your data protected, standardize how that data is collected, and integrate with other data, such as GPS, photos, RFID. You can integrate that stuff directly into your field data collection. And then finally, when you get back to the office, you can save time with data entry because you can just export to common formats like Excel or even synchronize directly to a database. All right, so here's an example in Salt Lake County with their stormwater inspection form. And this is using my favorite form software called Mobile Data Studio. Here's their form that they're filling out in the field on the left. Eventually, once you create your app, each of these gray sections that you see here, those are just being recreated in the app. So they have each of those sections show up on the app. And then when the user drills down into each of those sections, that's where they fill out the data that matches what they used to do on the form. That's the overall process. Here's how you do it. You have a desktop application generator side where you create your mobile app. You basically, again, you have your form here on the right, and all you're doing is recreating that inside of an app. And you have these data field types that you can select from, and you just recreate them exactly how you see them. And then it's always important to test the app before you go out into the field. So once out in the field, these forms, very easy to fill out, very user-friendly, a lot of touch screen, drop-down lists, a lot of big numbers that will pop up, so it's very easy to type things in. But it's very nice and easy for users to fill this information in. And there's a lot of features in these forms, and it's quite user-friendly. You can also integrate other types of data directly inside your app. So if you are taking photos, you can have those photos embedded. The user would just touch the place where the photo goes, and the photo camera is activated on the Mesa 2, and the photo is then integrated right to the paper form. But you can also do that same approach for GPS, barcodes, RFID, laser rangefinder, taking signatures, voice notes, even like a timer type application. Lastly, you can then, when you get back to the office, you have this simple view where you can look at all of the data that was collected in the field, and you can export it to common file formats like Excel, Google Earth, KMZ. You can also export directly or synchronize directly with a database such as SQL Server, Microsoft Access, and that's straightforward to set up. Again, you don't have to be a programmer or an IT whiz to be able to utilize this type of an approach. How much does it cost? Well, we already talked about the pricing for the Mesa 2 and the Geode. The software itself is quite inexpensive. It costs $200, which gives you the desktop ability to create as many apps as you want, and it gives you one mobile license for that. For each additional mobile license, it does cost an additional $100, but generally affordable, an affordable way to replace those paper forms and use them for many years to come. All right, that's really the last workflow that we're intending to present. We're hoping it was useful for you to look at some alternative options to what you may already have. We wanted to make sure that it's clear that there are discounts available for Utah governments. We also have a fair size evaluation pool of equipment, so you can evaluate equipment. And if you do have questions, be sure to type them in the box there. We're also excited about field data collection, so we're happy to discuss your data collection projects, provide recommendations. If you had ideas on migrating from your existing equipment, we'd be happy to help. But we're also happy just to make recommendations on any kind of field data collection that you might have. Please contact us here. I'm going to leave it here on with our contact information. We're happy to discuss your projects, and thank you for joining today's webinar. Lastly, we have recorded this webinar, so if you wanted to forward it to other folks, or if you wanted to view it again, we will be sending out a link to the recording in the future. Thank you again for joining the webinar, and have a nice day.